In the vast expanse of our solar system, beyond the familiar 8 planets lies a realm of icy bodies and dwarf planets. Among them is Eris, a distant world shrouded in mystery. Eris is often overlooked, overshadowed by its more famous cousin Pluto. Discovered in 2005, Eris challenged our understanding of the solar system and ignited a debate about the definition of a planet. This essay will delve into the enigmatic world of Eris, exploring its discovery, characteristics, and significance in our understanding of the cosmos. Eris was first observed in 2005 by a team of astronomers led by Mike Brown at the Palomar Observatory in California. This observatory, known for its significant contributions to astronomy, became the birthplace of a discovery that would challenge our understanding of the solar system. The team was conducting a comprehensive survey of the outer solar system, meticulously searching for distant objects beyond Pluto's orbit. Their goal was to map out the far reaches of our solar system, an area that had remained largely unexplored and mysterious. During their survey, they found a faint, slow-moving object that appeared to be more distant than anything they had seen before. This object, later named Eris, was not just another celestial body. It was a game-changer. Its discovery hinted at the possibility of many more such objects lurking in the distant corners of our solar system. The discovery of Eris sent shockwaves through the astronomical community. Scientists and astronomers around the world were both excited and puzzled. The existence of Eris challenged the long-standing definitions and classifications of celestial bodies within our solar system. Initially, Eris was hailed as the 10th planet in our solar system. However, its size and location sparked a heated debate about what constitutes a planet. The astronomical community was divided, with some advocating for its inclusion as a planet, and others suggesting a need to redefine the criteria for planetary status. The International Astronomical Union, or IAU, eventually stepped in to resolve the debate. In a historic meeting, they created a new category of celestial objects called dwarf planets. Eris, along with Pluto, was reclassified under this new category. This decision was monumental, as it not only redefined these two objects but also set a precedent for how we classify celestial bodies. This reclassification was not without controversy. Many in the scientific community and the public were resistant to the change, feeling a sense of loss over Pluto's demotion from planet status. However, this decision ultimately led to a more accurate and nuanced understanding of the diverse objects that populate our solar system. It opened the door to a broader exploration and appreciation of the myriad celestial bodies that exist beyond the traditional planets, highlighting the complexity and richness of our cosmic neighborhood. Eris resides in the outermost region of our solar system, far beyond the orbit of Neptune. This distant dwarf planet is one of the most intriguing objects in our cosmic neighborhood, offering a glimpse into the mysteries of the early solar system. This region, known as the Kuiper Belt, is a vast reservoir of icy bodies, remnants from the early formation of the solar system. The Kuiper Belt extends from the orbit of Neptune at about 30 AU to approximately 55 AU from the Sun. It is home to thousands of small icy objects, including dwarf planets like Eris, Pluto, Haumea, and Makemake. Eris's orbit is highly elliptical, taking it on a long and winding journey around the Sun. Unlike the nearly circular orbits of the planets, Eris's path is stretched out, causing it to travel vast distances over its orbital period. This elliptical orbit means that Eris experiences significant variations in temperature and solar radiation throughout its journey. At its closest, Eris comes within 38 astronomical units, or AU, of the Sun, which is still far beyond the orbit of Neptune. This perihelion distance places Eris in a region of the solar system where sunlight is faint and temperatures are extremely low. While at its farthest, it swings out to a distance of 97 AU. At this aphelion distance, Eris is more than twice as far from the Sun as Pluto ever gets, making it one of the most distant known objects in the solar system. To put this in perspective, 1 AU is the average distance between the Earth and the Sun, approximately 93 million miles. This means that at its farthest point, Eris is about 9 billion miles away from the Sun, a staggering distance that challenges our understanding of the solar system's outer reaches. Eris's orbital period is a staggering 557 Earth years, meaning it takes over 5.5 centuries for this distant world to complete one orbit around the Sun. This long orbital period is a testament to the vastness of the solar system and the slow, methodical dance of its distant inhabitants. meaning it takes over 5.5 centuries for this distant world to complete one orbit around the Sun. During this time, Eris travels through a region of space that is largely unexplored, offering scientists a unique opportunity to study the outer solar system and the processes that shaped its formation. The study of Eris and other Kuiper Belt objects continues to reveal new insights into the history and evolution of our solar system, reminding us of the vast and mysterious nature of the cosmos. Section 4. Unveiling Eris: Size, Mass, and Composition. In this section, we will delve into the fascinating details about Eris, one of the most intriguing objects in our solar system. We will explore its size, mass, and composition, and how these characteristics compare to other celestial bodies, particularly Pluto. Eris is a relatively small world, with an estimated diameter of about 2,326 kilometers, or 1,445 miles. This measurement places Eris among the smaller dwarf planets in our solar system, yet it holds significant interest for astronomers and space enthusiasts alike. This makes it slightly smaller than Pluto, which has a diameter of 2,377 kilometers, or 1,477 miles. The comparison between Eris and Pluto is particularly interesting because it highlights the diversity of objects in the Kuiper Belt, a region of the solar system beyond Neptune filled with icy bodies and dwarf planets. Despite its small size, Eris is more massive than Pluto, with a mass about 27% greater. This increased mass is a key factor in understanding the physical characteristics of Eris and how it differs from other similar-sized objects in the solar system. This difference in mass suggests that Eris is denser than Pluto, indicating a different composition. Density is a crucial aspect when studying celestial bodies as it provides insights into their internal structure and the materials they are made of. Astronomers believe that Eris is composed primarily of rock and ice, similar to Pluto. The combination of these materials suggests that Eris, like many other objects in the Kuiper Belt, formed in the early solar system and has remained relatively unchanged since then. Its surface is thought to be covered in a layer of nitrogen, methane, and carbon monoxide ices, which gives it a reddish hue. This reddish hue is a result of the interaction between sunlight and the ices on Eris's surface, causing chemical reactions that produce complex organic molecules known as tholins. The presence of these ices suggests that Eris has a very thin atmosphere, which may freeze and fall to the surface as snow when Eris is farthest from the Sun. This phenomenon is known as atmospheric collapse and is a common occurrence for distant objects in the solar system. When Eris moves closer to the Sun, some of these ices may sublimate back into a gaseous state, temporarily replenishing its thin atmosphere. This cyclical process of freezing and sublimation is a fascinating aspect of Eris's behavior and provides valuable information about the conditions on distant dwarf planets. Eris's orbit around the Sun is highly elliptical, taking it from about 38 astronomical units, AU, at its closest approach to about 97 AU at its farthest point. This wide range in distance from the Sun means that Eris experiences significant variations in temperature and solar radiation, which in turn affect its surface and atmospheric conditions. As a member of the Kuiper Belt, Eris shares its region of space with many other icy bodies and dwarf planets. This distant and mysterious part of our solar system is a treasure trove of information about the early solar system and the processes that shaped it. Studying Eris and its neighbors helps astronomers piece together the history of our cosmic neighborhood and understand the diversity of objects that exist beyond the traditional planets. Future missions to the Kuiper Belt, including potential visits to Eris, hold the promise of unlocking even more secrets about these distant worlds. By sending spacecraft equipped with advanced instruments, scientists hope to gather detailed data on the composition, geology, and atmospheres of these intriguing objects, providing a clearer picture of their origins and evolution. In conclusion, Eris is a small yet fascinating world with unique characteristics that set it apart from other objects in the solar system. Its size, mass, and composition offer valuable insights into the nature of the Kuiper Belt and the early solar system. As we continue to explore and study these distant realms, Eris remains a key piece of the puzzle in our quest to understand the universe. Section 5. A Tale of Two Dwarfs, Eris and Pluto. Eris and Pluto share many similarities. Both are dwarf planets, both reside in the Kuiper Belt, and both are composed primarily of rock and ice. However, there are also some key differences between these two distant worlds. As mentioned earlier, Eris is slightly smaller than Pluto but more massive, suggesting a denser composition. Eris's orbit is also more eccentric and inclined than Pluto's, taking it much farther from the Sun. These differences in size, mass, and orbit provide valuable insights into the formation and evolution of the Kuiper Belt and the early solar system. Section 6. The Scattered Disk, home to Eris and its kin. Eris is classified as a scattered disk object, a subcategory of trans-Neptunian objects that have been gravitationally scattered by Neptune into highly eccentric and inclined orbits. The scattered disk is a region of the outer solar system that overlaps with the Kuiper Belt but extends much farther out. Objects in the scattered disk are thought to have formed closer to the Sun, but were flung outward by gravitational interactions with the giant planets, particularly Neptune, during the early evolution of the solar system. Studying these scattered objects like Eris provides valuable clues about the dynamical history of our solar system and the processes that shaped its current architecture.